Hello everyone, this is Mrs. McCreary. Today we're going to start talking about proportions. As you read in Elementary Treatise, we have now finished what would formerly be considered arithmetic, dealing with addition, subtraction, multiplication, and division of all the different kinds of numbers. We've dealt with regular simple numbers that are just, what we would think of as whole numbers. We've dealt with fractions of all sorts of different types, and then finally decimal fractions. And so now we're going to start going through proportions, ratios and proportions. We've talked about ratios a little bit before, and now we're going to start talking about them more in an application sense. In Elementary Treatise section 108, it says that this is often considered part of algebra because there are some different ways of solving that you can use, but you can also just kind of logically think your way through it, and we'll talk about both of those ways. But right now we're going to talk about just what a proportion is. In Pure Mathematics, section 38, it says, in every proportion, the product of the extremes is equal to the product of the means. Now before we get that far, a proportion is two ratios that are set equal to each other. So I believe the example they have is 6/8 is equal to 15/20. And of course, if we reduce that down, we can divide by 2 here, and we get 3/4, and divide by 5 here, and we get 3/4. We see that that is equal. However, if we treat it as a ratio, we would have 6/8, 15/20. Now, we can see here that we have our extremes and our means, just like we were talking about those compound fractions. And we can also, of course, write it in more compound fraction form. So we would have 6/8 over 15/20, which then still we have our means and our extremes. Now, all of this is fine when we're dealing with numbers and everything works out. Of course, when we have 6 times 20, that's 120. And then 8 times 15 is also 120, so we can see that those are equal. The difficulty comes in when you are missing one of these means or extremes, and that's when we need to apply some problem-solving skills. So in Pure Mathematics section 39, it says, if the required term be a mean, divide the product of the extremes by the other mean. But if the required term be an extreme, divide the product of the means by the other extreme. And we'll talk about what all that means as we go through those examples from Elementary Treatise. So the first example is, a piece of cloth 13 yards long was sold for $130. What will be the price of the piece of the same cloth that is 18 yards long? In Elementary Treatise, it talks through the logic of thinking, okay, well, 13 yards for $130, that's clearly $10 a yard, so 18 yards would be $180. If we wanted to discuss more of the pure mathematics method, where we're talking about the means and the extremes and the proportions and the ratios, we would need to set it up as a proportion or as a ratio. Now, the important thing that you remember while you're working with this, we have two different things that are being labeled. We have yards, dollars, and yards, and then it's asking for what the other dollar would be. Now, when you set up your proportion or when you set up your compound fraction, the thing that you need to remember is that yards and yards need to be on the same part. If you decide you want this part, the 13 and 130, if you want it to be a 13 over 130, you need to make sure that your 18 yards is at the same place in its proportion, or if its ratio. Now when you do that, I'm going to use our x here, or actually, why don't I go ahead and use a dollar sign? It doesn't really matter. X is, you're going to use variables such as x's and y's and z's when you get into algebra, but it really doesn't matter. These symbols are just holding a place for something we don't know, and we call those variables. Now, going back to this pure mathematics, let's go ahead and rewrite it as a compound fraction. So it would be 113 over 130 over 18 over however much money that is. So we have our means, we need one of our extremes. Okay, so what we're going to end up doing, we're going to multiply 130 times 18 and then divide that value by 13. All right. Over 13 is then going to give you how much money it would be for the 18 yards of cloth. All right, let's go ahead and look at this second example. A courier who always travels at the same rate, having gone 5 leagues in 3 hours, how many leagues will he go in 11 hours? So again, we're dealing with hours and leagues. We want to make sure that our labels are on the same part of our ratio. So I'm going to do, I'm going to go ahead and put 3 hours on top so we keep our numerator smaller, although it really doesn't matter. So 3 over 5 is equal to, now 3 is my hours, 11 is hours, so I'm going to put 11 on top over x. Now again, we saw here that when we did our means, we have our denominator from the first and our numerator from the second. Alright, so those are going to multiply together and then be divided by this numerator. Okay, so we're going to end up with 5 times 11 divided by 3. We could, of course, rewrite it as 3 over 5 over 11 over x. Find our means and our extremes. Either way, it's going to give you 55 thirds equals, you could reduce that, and that would be how many leagues he has gone. All right. So one more example. In how many hours will the courier of the preceding question go 22 leagues? Okay, so again, we're starting with the same 5 leagues in 3 hours. That's our starting point. Just for fun, I'm going to change things around. So 5 leagues in 3 hours. And how long will it take him to go 22 leagues? And we don't know this. So we can rewrite it as a compound fraction. So we will have 5 over 3 over 22 over our unknown value. So we do our means and our extremes. So it gives us 66 over 5 because we're dividing it by our extreme to find our other extreme equals x, and then of course you would go ahead and reduce that. What you really want to do is you just want to think, I want to get this value isolated by itself. So you would be starting with 66 equals 5 times that value, and then you divide by that 5 to get that value by itself. And that's really what you want to do. You just want to get that by itself, or you can just logically think through it as they do in elementary treatise. And again, you're not using any complicated calculations. You just have to think through all the steps. Although again, in pure mathematics, you remember there's the means and the extremes. You're going to multiply the two that you have and then divide by the other one. And again, as you're setting this up, it really doesn't matter where the variables go. For instance, I could have 3/5 equals x over 22, and then those two still go together. 3/5 over x 22. These now have become my extremes and these are my means, but I'm still going to divide my other mean, or divide the product of my extremes by my other mean to get that variable by itself. So I'm still going to end up with 66 over 5. And again, there are a lot of ways you can set up these proportions. The important part is to make sure that your labels are matching up with your numerators and your denominators. As always, go ahead and write down any questions that you have. Send them to me in email form. Again, trying to be as specific as possible in emails, or if you're using the discussion boards, to eliminate lag time as we try and narrow down the question. And then, of course, bring any questions that you have to our live chat, and we can work them out there. But hopefully everything goes well. I will talk to you guys later.